Welcome, my name is David Freeling and I'm going to guide you through a very useful test prep strategy called testing the answer choices. It can be a great way on a standardized test like the SAT, GRE, GMAT, HSPT of obtaining the right answer when you're kind of stuck and don't know how to do a problem. The basic idea is there any way to use the answers they show you, work backwards, put them into the original question, and find your answer in a creative way by seeing which of the various choices is consistent with all the information you've been given. Let's say you see a typical question like this one. If 4 to the x plus 1 power equals 8 to the x minus 1, what is the value of x? You may be surprised to know that if you have one of these, a calculator, you can do this question without knowing all that much math. Let's take a look over here at the answer choices. 3, 4, 5, 6, or 7. And for a moment, why don't we imagine that the answer is letter A, x equals 3. Now if that were true, I could put in 3 as x and I'd get 4 to the 3 plus 1, 4 to the 4th power. I type that into my trusty calculator, which shows me 256 as the value of the left side. On the other hand, 3 for x would mean this would read 8 to the 3 minus 1. That would be 8 to the 2nd power. I type that in, and the calculator shows me the value 8 squared, 64. For the right side, those are not equal, so I know the answer cannot be letter A. Next I move on to choice B, and I imagine that 4 is the value of x. 4 plus 1 is 5, so the left side now reads 4 to the 5th power. Once again, I go back to the calculator and obtain the value of 1024 for the left. That same number as x would yield 4 minus 1, or 3 as the exponent on the right side. I type that in, 8 to the 3rd power, 512, and again, they're not equal, which means letter B cannot be right. Now let's look at what happens when we get to letter C, suggesting that x equals 5. 5 for x would make the exponent up here equal to 6, meaning that the entire left side would read 4 to the 6th power, or 4096 according to my calculator. If x did equal 5, then the right side would equal 8 to the 5 minus 1, or 8 to the 4th power. When I type that into my calculator, lo and behold, it shows me that same value, 4096, and therefore I know letter C is the answer because it made the two sides of the equation match in value. Students, we've already solved this problem once using our sneaky testing the answer choices method. I would still like you to know the math behind it, so let's just go into that for a moment. The key to solving these exponent questions is often to find a common base. The key observation here is to note that 4 could be written as 2 times 2, or 2 squared, and that 8 is equal to 2 times 2 times 2, or 2 to the 3rd power. Armed with that knowledge, I can substitute 2 squared for the 4, and 2 to the 3rd for the 8. Once I've done that, I can use one of our rules for exponents called the power to a power rule. Here's your typical example. X squared all to the 3rd power equals x to the 6th. You may notice that we're multiplying the exponent. 2 times 3 equals 6. If I apply that basic rule to the problem at hand, I get 2 to the 2x plus 2 on the left equals 2 to the 3x minus 3 on the right. What I've done is multiply the exponents. At that point, since both sides have that common base of 2, I could almost cancel the 2 out completely and simply set the exponents equal to each other. Therefore, 2x plus 2 equals 3x minus 3. Adding 3 to both sides and subtracting 2x from both sides would yield 5 equals x. So here's the official way of doing it. And the second way, of course, was working backwards from the choices. Just so you know I'm not making these up, the problem at hand comes from page 891 in the official SAT guidebook put out by the College Board. If you have it, look at page 891, number 15. So today we're focusing on some of the sneaky stuff for outsmarting the challenging problems you might not otherwise know how to do. Specifically, testing the answer choices was a way of using choices you've been given to work backwards and get the answer. Now what about on a question like this when they give you no choices? Let's look at it. If 2 to the x plus 2 to the x plus 2 to the x plus 2 to the x equals 2 to the 7th, what is the value of x? Here they gave you no choices, and yet we could try to think of a few using some estimation. I can look at that and see that x would be less than 7. Since the right side is 2 to the 7th, if you had a few 2 to the 7ths added, that's going to be more than just a single 2 to the 7th. And if you can spot that, you can maybe think of a few numbers that could be potential answer choices that we can test out as x and see which one actually works. If x is an integer, it would have to be one of these 6 or 7 choices. Let's start with maybe right there, the one in the middle. Suppose x equals 3. Now the left side reads 2 to the 3rd plus 2 to the 3rd plus 2 to the 3rd plus 2 to the 3rd. Now go to your calculator and start by getting a value for the right hand side. I'll type in 2 to the 7th power, and I obtain the value 128 for the right-hand side. On the left, I once again go to the calculator and type in 2 to the 3rd power. Well, that's only 8, and if I add it to itself 4 times, it's only going to be 32, not 128. 3 was too small, and I can knock out all those choices. Let's try one of these values like 4, 5, or 6. Maybe x happens to be 4. Then I'd have 2 to the 4th written out 4 times. Again, I go to the calculator and type that in. 2 to the 4th happens to equal 16 times 4, and I get a value of 64, which does not match 128. Therefore, I know 4 is incorrect. I'm closing in. Let's see if 5 might happen to work. When I put in 5 as x, the left-hand side would read 2 to the 5th plus 2 to the 5th plus 2 to the 5th plus 1 more 2 to the 5th. Simply entering these numbers on the calculator, I get that 2 to the 5th is 32. Added it to itself 4 times would be like multiplying it by 4. And the calculator shows me 128, matching the value 2 to the 7th that I got earlier, and therefore I know that x does in fact equal 5, and there I have my answer, even though I knew very little about how to work with exponents. Students, we just saw a sneaky way of how to solve this question. What is x if 2 to the x plus 2 to the x plus 2 to the x plus 2 to the x equals 2 to the 7th? I'd also like you to learn the actual math behind it. Like many exponent questions, it can be solved by working with a common base. Let's look at how that works. Since I have 1, 2, 3, 4 2 to the x's, I could write the left-hand side as 4 times 2 to the x. Now if you think about that number 4, you'll probably remember that 2 times 2 equals 4, so 4 could also be written as 2 squared. Next we'll invoke some of our useful rules for exponents. Here are the 2 most common. X squared times x to the 3rd equals x to the 5th. Adding the exponents when multiplying with a common base. And that's the one we're going to use right here, which lets me transform the left-hand side into 2 to the 2 plus x power. Adding the bases, adding the exponents when you have a common base. From here, it's quite easy to see that if you want the left side to match the right side, the 2 doesn't really matter, and 2 plus x must equal 7. From there, simply subtract 2 from each side to obtain your answer, x equals 5. Matching the same value we had when we tested the answer choices. Okay, welcome back. We're developing strategies for testing the answer choices. If you're taking the SAT, the problem at hand comes right from the official guidebook, so compare to page 414, number 5. The question here asks you, what is the shaded area for this portion of this circle? Now, if you take a quick look at the answer choices, it can give you a good way to estimate your answer even if you're unsure how to do it. Now, a quick inspection of choices A, B, C, D, and E here shows you that the choices are in order. And let's take a look at letter C for a moment. Maybe the shaded area is equal to pi. I see there's a circle involved. And most of you remember pi is about 3.14. Now, take a look at the square for a moment. They told you in the problem it's a square, meaning 2 by 2, and so most of you could figure out quite easily the area of the full square is equal to 4. Now, does this number seem sensible as the shaded area? No way. If you take a look at it, and we're just trying to guess what that shaded area, it's definitely less than half of 4, and you might guess that there's 2 units of area to the left, 2 to the right, and that the shaded is about half of 2 and equal to 1. Now at this point, if you were just going to guess and pick the choice that happened to be equal closest to 1, you'd happen to get the right answer. You know that pi is going to be too big, and D and E, which are both larger than pi, will also be too big, and you could almost settle for a 50-50 guess here. But let's go ahead and show you the official way of doing it. When you get on your test though, I'd like you to keep your eye out for these ways of narrowing down, estimating, and eliminating the choices that you know couldn't work. Now a quick inspection of the diagram would show you that approximately 1/4 of the full circle has been shaded. And so that if you could figure out the area of the full circle, you would be able to figure out the 1/4 of that would be the shaded area right there. Now to find the area of the full circle, we'll need to find the circle's radius, which is actually quite easy. If the whole length across is 2, then the radius across here equals 1. Now on the test, they'll give you the formula for area right at the beginning, pi r squared, not a bad one to memorize. And now that you know that your radius is 1, you can fill that in, meaning that the area of the whole circle is pi. Thinking back to what we said, 1/4 of the circle's been shaded. Therefore, my area of just the shaded sector would be 1/4 pi, matching our initial guess and estimate.